So in this lesson, we're going to look at how we can evaluate imaginary numbers with exponents. So we're going to establish imaginary number exponent, and we're going to apply exponent rules in simplifying imaginary number exponents. Important thing to note here are some basic exponent rules. A multiplied by B together having an exponent n is the same as a with an exponent n multiplied by b with an exponent n, and a to the power of m multiplied by a to the power of n is the same as a to the power of m plus n, and a with an exponent of m and that expression with an exponent of n is the same as a with an exponent of m times n. Important thing to remember is that I squared is equal to -1, so I to the third power is I squared multiplied by I to the power of 1, borrowing from this product rule here of exponents. And I to the fourth power is I squared all to the power of 2, and that is borrowing from this exponent rule here. So 2i to the third power is going to be 2 to the third power multiplied by I to the third power. 2 to the third power is 8. I to the third power from what we see here is -i. So 2i to the third power is -8i. 3i to the second power is going to be 3 squared multiplied by I squared. 3 squared is 9. I squared is -1. So this is going to give us -9. 4i to the fourth power, so that's going to be 4 to the fourth power multiplied by I to the fourth power. 4 to the fourth power is 256. I to the fourth power is 1. So this is going to give us 256. Now we're going to apply exponent rules. One of the things that we established earlier is you have I to the power of 1 is equal to I to the power of 2 is -1, I to the power of 3 is -i to the power of 4 is +1. So now I to the power of 5, here's how we're going to apply our exponent rules, is going to be I to the power of 4 multiplied by I to the power of 1. I to the power of 4 is 1, and then we have I. So this is going to give us I to the power of 5 is the same as I to the power of 39. So I to the power of 39, let's divide 39 by 4. So we divide 39 by 4. We have 9 and we have a remainder of 3. So this is going to give us I to the power of 4 to the power of 9 multiplied by I to the power of 3. So you can say this is 36 plus 3. So I to the power of 4 is 1 to the power of 9, and then I to the power of 3 is -i. So this is going to give us 1 multiplied by -i, which is -i. I to the power of 66, we take 66, divide by 4. We have 1 here, 4, we have a remainder of 2, and then we bring down the 6, we have 16, 24, we have a remainder of 2. So I to the power of 66 is the same as I to the power of 4 to the power of 16 plus, rather. So this is multiplied by I to the power of 2. So you can observe a pattern. We divide by 4 and create the multiplication rule on the exponent here, and then we multiply by I to the power of the remainder, which is 2 here. So this is going to be 1 to the power of 16 multiplied by I squared is negative 1. So this is 1 multiplied by negative 1, which is going to give us negative 1. Final example. So 96, we divide that by 4. We have 2 times 4, 8, subtract 1, 6, 16 by 4 is 4, 16. So I to the power of 96 is the same as I to the power of 4 to the power of 24. So this is going to give us, and then multiplied by I to the power of 0, because that's the remainder. So I to the power of 4 is 1 to the power of 24 multiplied by 1. So this is 1 multiplied by 1, which is going to give us 1 as the solution. So this is how you manipulate exponents. When you have imaginary numbers with exponents, this is how you manipulate the exponents.